Okay, fourth graders, so we are here on page 329, still in lesson 9 of unit 8. We just took apart quadrilaterals to make triangles. Now they're doing the opposite. They're taking triangles and putting them together to build quadrilaterals. So this takes us back to a lot of things we've done in math. We've used the word decompose a lot, where we have something, we take it apart, and we put it back together. And we've talked about the reason we do that is so that we have a deep understanding of how things are working. You might remember when we did that in fractions with unit fractions. We've done that in many, many different areas of mathematics this year. So looking at the triangles here, this says cut out the triangles. For each exercise, glue 2 of the triangles on this page so that the stated sides are joined. You can do this at home if you want to. You certainly don't have to because you're going to be turning in your work in Clever again today. But it is kind of fun to play around with, especially if you're finding these shapes confusing. Getting that hands-on experience, doing some cutting, putting things together is a really good idea. On the next page, 330, you're going to be matching quadrilaterals with triangles. So the directions say to name the triangle that is used twice to form each of the following quadrilaterals. What kind of triangle is it? Then list all names for the quadrilateral. Whew, so again, a lot of stuff going on here. On number 10, I see that there's 2 different triangles. Both of those triangles are right triangles. And then I have to look up here to see which triangle was used. Okay, so it looks like it's the orange one, right? Triangle V. So I could say V there for the triangle that's used. What are the names of the quadrilateral? All of them. So again, you're going to see so many names used. And it's simply because it's a hierarchy. There's so many different ways that you can describe quadrilaterals. We have a parallelogram, we have a rectangle. Is it a square? No, it is not a square because all of the sides are not equal. Is it a rhombus? No, it is not a rhombus because again, all of the sides are not equal. So there are some things that it is not. All right, looking at 11, trying to figure out which shape that would be up there. It looks like W to me, right? Maybe it's better if I label them inside there like that. This is definitely a parallelogram because again, it has 2 sides that are parallel to each other. I'm looking at it and trying to decide if it's a rhombus. Remember, a rhombus has all the sides equal. I'm going to go with yes. I believe that those are all equal. Without a ruler, it's a little bit tricky for me to tell, but as long as I know the reasons behind my answer, that's fine. I just have to be able to defend myself. So if I say those sides all look the same length, therefore it's a rhombus, I'm good to go. That's fine. Number 12, looks like we've got a Z in there. Again, definitely a parallelogram. Maybe not a rhombus. If you have a ruler at home, you could check me out on that and see. Here we've got triangle, oh, triangle Z again, but they've put it together in a different way. Interesting. Again, not a square or rectangle because I don't see any right angles. And here we're going to go with X on both of those. And again, it is not a square or a rectangle because the angles are either acute or obtuse. Okay, we've got one last page. This is a hefty lesson today, isn't it? We're going to be drawing perpendicular lines in triangles. So another vocabulary word that we need to know is a vertex. It is a point shared by 2 sides of a polygon. Basically, it's corner. You can think of the word corner when you think of vertex. So the first one here says draw a scalene triangle ABC. Ooh, going back to what we've learned about scalene. Do you guys remember? Scalene means that all the sides are not the same length. So I'm doing my best to sketch a triangle there where all the sides are different. You let me know how I did, but I think I did okay. And then, of course, the answer to this is what's true. They are not all the same length. Now, the next step, draw a segment from one vertex so that it is perpendicular to the opposite side. Whoa, there are so many vocabulary words in here. Go ahead and circle them if you've got your book in front of you. Vertex, perpendicular, opposite is another word that we looked at earlier. Okay, so a vertex, remember I said that that's a corner, so I can make a nice point there on the corner to help me answer this question, and then it says simply to draw a line so that it goes to the opposite side, and then it has to be perpendicular. So looking at that, you can see my drawing there. You're going to have to do this somehow on Clever for this lesson. It'll be interesting to see how they work that out. Name triangles that are formed. So again, if you're naming these A, B, and C, see if you can put in the names of the triangles. Sorry, I took that off the screen. A, B, C. See if you can put in the names of the triangles. And then the next exercise at the bottom is doing the same thing except with an isosceles triangle. Do you remember that isosceles comes from an old word that means two legs that are the same length? If you can remember that, then isosceles triangles are a little bit easier to remember because you've got two sides that are equal to each other and another side that might not be equal to those. Oh my goodness, there is one more page of this lesson. This is a crazy lesson. So you're drawing perpendicular lines in triangles. This is just continuing from the page before. Again, you're going to be working with this on Clever, so I'm not too worried about it if you don't get through everything in your book. I think they just gave us lots of examples because there's so much going on. And then you have a nice letter from Puzzled Penguin. Of course, he messed up again. At least I assume he did because he always does. Dear math students, I tried to do exercises 20 through 23 again using an equilateral triangle, PQR. I found that PS line segment PS and line segment RS that I formed are not each half the length of side PR. Oh, I see. What did he do wrong here? He's got two lines down here that are not the same length. So for example, that one, the pink one, and then the green one here. I think I know what he did wrong. He didn't draw a line that was perpendicular to the opposite side. So his line should have been like this, and then he would have been able to solve his problem. Okay, fourth graders, let me know if you have any questions. I know this is a big lesson today, so just do your best, and I will get to see how you did on your Clever assignment, so that'll help me know how much of this you understand. Have a great day.